have the book on the list. Because that's one of the important parts. Because if you look at my list, it's pretty varied. The only thing I don't currently have on there is a book of poetry. I gotta find one. I'm sure there's one out there. I gotta find one. But each book was picked for a particular reason. And I've now, over the course of the last 3 months, there have been about 3 more that need to be added to my list. Yeah?
So, like, I know there's a lot of books on there that I think have nothing to do with, like, actual, like, engineering stuff, like, you know what I mean?
Yeah, sort of.
You can, like, kind of connect it. I guess I've been reading it, and I've been, like, trying to think.
Which book are you reading?
The Moralist.
Okay, okay.
Andre Giddy.
Yeah. Yeah, he's reading The Amoralist, and it's not a specific engineering book, correct? Actually, most of my books on the list aren't specific engineering books. So, go on with your question.
Anyway, so I guess you just kind of use what you think would help an engineer, I guess, to kind of connect it somehow? Is that what you just...
Mm-hmm. Or there might be a concept in there that that as engineers we have to be aware of. Okay? Might be concepts in there as engineers we have to be aware of. That, or we can take a couple of them. There are some of them that are picked because they, looking back, were very influential. Okay? Looking back, were extremely influential. And in fact, I've been laughing. Depending on which way you get your television service, so let's talk about that for a second, television service. 2 years ago, I would say, well, actually, I've done the study. I teach a class in communications for the American Chemical Society, and I've been doing this now for about, it's getting on 10 years now. And I talk about communications to the public and how we approach communications to the public. So 10 years ago, most people got their day standard TV through cable, right? If you think about it, in 40 years ago, 1979, most people got 3 stations, ABC, CBS, NBC. You got an OETA here in Oklahoma, some sort of PBS station. So there's 4 stations. And if you were lucky, you got 2 or 3 UHF stations. Okay, ultra high frequency stations. And about 70, because I remember getting our first color TV. This kind of dates me, right? First color TV we got in 1972. Color TV was out before then, but our first color TV was 1972. And in fact, I had a usable black and white television that I used all the way through grad school, and I graduated with my PhD in 1989. I did my thesis defense the Friday before the Exxon Valdez ran aground. It tells you kind of interesting things where people changed. But 1989, I was still using a black and white television set that I had in my spare room. And my cable box was connected by wire. We didn't have any Wi-Fi. So if you think about how you got your TV, cable started coming in the 80s. Right? Cable started coming in the 80s. And I think Dish, the big dishes, they started in the 90s. So the big dishes started in the 90s, and Dish Network's probably in the 2000s. So cable was probably up until about 10 years ago. I would say when I would go to my classes, and my classes that I teach are East West Coast, that about 90% of the people would get their television through cable or Dish Network or whichever one it is. So that tells you. Starting about 3 years ago, that number who got their TV through cable precipitously fell. Most started going to Dish, but I will tell you as of the last 18 months, I would say the majority of people, at least on the East-West Coast, still around here, you're kind of limited, but on the East-West Coast, you were still getting through cable and Dish. Now, I would say the majority of people get their television through some sort of streaming service. be it Sling, be it Hulu, be it Netflix, be it Amazon Prime, be it individual apps. If you like CBS, you may have your CBS app. If you like ESPN, you may have your ESPN app. You know, but your TV, your change over of how you get your television has drastically become different. And that is an interesting piece. But the whole idea behind that is we're using Hulu at the moment. I've used Slings. I really did like Sling. But Hulu has the ability to get some local television news. And so that, you know, around in Oklahoma, if you don't get Channel 9 or Channel 6 for weather, you're in trouble, right? Because they're even better than the Weather Channel, right? So we gotta keep up with weather. So that's why we ultimately had to switch. But Hulu has the $6 Million Man. Gotta love it. Look at the technology in the $6 Million Man. About the only thing they haven't been able to do is do the actual network connection between his bionic eye and the brain. Just about everything else they've been able to do some sort of fashion. To the point that they banned a para-athlete from the regular Olympics because his artificial legs gave him an advantage.
That's pretty awesome.
I mean, we're talking what technology, you know, and I think $6 Million Man was out late 70s. So you start, you know, Star Trek. About the only thing that we haven't been able to do out of Star Trek is beam me up. That's
I'll have
about.
to find it, but I was pretty sure I read an article about they're using. This is something that one of Elon Musk's companies is doing, but they're able to actually attach some very specific fine wires to different nodes of the brain to control motor function. And
Oh, yeah.
They're going to use it to use like an interchange between the human brain and computer systems.
Yep, that's happening. And like I said, the only thing about the $6 Million Man, it's the optic nerve piece, because they have done now where your brain can actually learn how to manipulate an artificial limb through signals that you can actually connect through the signals. And last week there was a paper out where that now they've actually, that sense of touch in an artificial hand, that they've got some work right now that actually says that sense of touch, that there is at least for terms of pressure, is actually getting into artificial limbs as well. So, which is now kind of, so and part of that's coming from artificial intelligence and the robotics, because you have to be able to teach a robot the sense of touch so it doesn't crush an egg, or so it doesn't do that without necessarily programming that information in. So there's some of that that's going on. So, and cyborgs are real. So if you want to take the next jump to Star Trek and more of the Star Trek The Next Generation, cyborgs are real. They've actually built them with and the two tissues of choice are related to sea slugs. Sea slugs have some really cool tissues that they can do, manipulate some mechanical bugs and actually have a part living, part mechanical device. So cyborgs are real. They're kind of creepy, but they are real. And there is even the beam me up part from the original Star Trek series. There are experiments where they have been able to take inanimate objects from one side of a room to another side of a room, and there's some evidence that you can have it dissolve over here and reappear over there. And if you really want to get technical, what's Impossible Burger and Beyond Meat? That's test tube plant-based proteins that are the amino acids that you actually get in meat. So, you know, we have some creepy
What
stuff.
is what kind of energy cost is that to?
Well, that's my argument right now. My argument right now is I don't think anybody's done the life cycle associated with all the energy from the growing of the plant to do the conversion to go forward to bring it all the way back around. I don't know, and I don't even know what the carbon footprint is.
Well, I was talking more about the teleportation.
Oh, the teleportation one? I honestly don't know. I honestly don't know. I just know I've read a couple of different experiments where they think they've done it, but it's also in that spot where did they really do it or not? So, but there, and just 2 weeks ago, there's a paper as to why we probably will never beam me up people.
Does it say because if you completely take somebody down to atoms, send them through a communication line or whatever, and then reassemble them, they're going to be a potato?
Well, not so much that. That's not so much what they're worried about. They're worried about things, and part of it comes back to this idea of quantum computing and how our brain stores memories, how our brain stores stuff, that's probably what we won't be able to reproduce. So you could probably have the right physical form, potentially. You could probably recreate it, because we do that now, sort of, right? We do that now, sort of, in terms of cloning, in terms of 3D printing, because there's a lot of things that now you can 3D print DNA tissues. You can 3D print. You can order up whatever DNA you want. So we can kind of do that part now. What we can't necessarily recreate are memories. Although, if anybody's watched Total Recall, right?
Yep.
It's a short story. You can remember it for me wholesale. Yeah. So that gets it back to our book here. So.
I was wondering, have you read anything about Einstein's theory of relativity being stolen from Jules Henri Poincare?
I've heard all kinds of things, and then there's the conspiracy theory that Tesla's papers were stolen by the FBI. So, there's a lot of those things that are out there. The big thing is, and that's one of the issues that we talk about in terms of scientific knowledge, because there's a lot of stuff. I'll give you two for instances. One is the Hall process for being able to produce aluminum. Aluminum is the most abundant element in the earth, right? Aluminum oxide is totally abundant. But up until the Hall process, and I cannot remember the other guy in Europe, but the Hall process actually was able to isolate aluminum from aluminum oxide, which now makes aluminum pretty ubiquitous. We would not have aluminum foil, aluminum cans, any of those kinds of things without the Hall process. But it's called co-discovery or simultaneous discovery. That the prepared minds, based on everything that comes together, the idea will show up almost instantaneously in two different locations. So you have a lot of that, and then there's a lot of argument. Well, did so-and-so know what so-and-so else is doing, and was there contamination across the way? And that's a lot of discussion in patents, whether or not there was contamination. And you have a lot of that piece back in there. So Hall actually invents the Hall process. And then there's also the part about credit, okay? We always use the part about credit, that the Hall process may not only have been his, but a combination of his and his sister's. But his sister never really gets the credit at all, partially because of time and partially because there's not as much evidence as to what she may or may not have done in that respect. So you get that part. And then you get the person over in Europe who also comes up with the process. And it turns out in the case of the Hall process, it's very easily documented that Hall came up with his process approximately 3 weeks before the other guy did. And there's also good evidence, which is why this is a really good example of what they call simultaneous discovery, because in that case, there wasn't even an exchange of papers between these two individuals, which is different than Newton and Laplace, or one does integral calculus, one does differential calculus. They're across the channel from each other. There's actually correspondence between the two. So the question becomes, were they exchanging ideas related to mathematics? None of the papers that have currently been found says yes or no. And you end up with simultaneous discovery of the mathematics that we now use. One is the integral form and one is the differential form. So you get that one. The other one, the one that I am personally familiar with, because I have actually talked to the individuals, or actually talked to one of the individuals involved, and unfortunately, Banks was deceased before I started working with Phillips Petroleum. But Paul Hogan was one of the inventors of polyethylene polypropylene, and they have the patent. There was a 17-year-old patent dispute that went on with regard to who actually invented polyethylene polypropylene. Ziegler Natta is usually given the credit because they won the Nobel Prize for the processes by which polyethylene and polypropylene are. But it is well founded, it is a documented fact that Hogan and Banks had done it long before Ziegler and Natta did. The prime problem was Ziegler and Natta were in the university system, Hogan and Banks worked for industry, and they kept everything secret until the patent applications went forward. And Ziegler and Natta could write academic papers. And they ended up with the Nobel Prize, but Hogan and Banks end up with the patent. Again, it's kind of co-discovery of what was going on. And actually, Ziegler and Natta are about 9 to 12 months behind Paul Hogan and Banks. So it's kind of an interesting, there was actually a bigger gap between what Ziegler and Natta did versus what Hogan and Banks did in terms of polyethylene polypropylene. So we have a lot of interesting dynamics of co-discovery. So you'll see that a lot. You'll see a lot of discussion about, did so-and-so take somebody's idea? Did so-and-so, was that idea out there? Did that idea occur? When you guys get to Engineering Physics 2, and the two of you will get to hear it on Wednesday, you're going to hear a lot about these debates where the ideas are shared and where theories go off into some direction and come back together to get where we are today. And that's where we end up with some interesting characters along the way, and we end up with some interesting who gets credit and who doesn't get credit. And those are lots of big debates about a lot of different things. So back to our book reports. Now you have some basis for why I may put certain things on the list. Okay? May put certain things on the list. Because there are certain some aspects of things that are going on. And it also starts to talk about, and I don't have any books that are in a new genre, a new literary genre. And the new literary genre is, although Fahrenheit 451 probably is a precursor of this new genre, and the new genre is associated with climate change. And you got to think about when Fahrenheit 451 was written. Okay? Got to think about when Fahrenheit 451 is written. Kind of an interesting aspect to what we're seeing now in terms of climate change. But there's a whole genre now about what happens if the world did this. And the other new genre that's out there is revisionist history. Man in the High Castle is a perfect example of what happened if Germany had won the World War II, or if Germany and Japan had won World War II. What would have happened if the South did not, if the Civil War didn't end the way it did? There's some interesting pieces that are out there along those lines that are kind of some interesting aspects of some literature that really calls into question certain realities, and we have to think about it. So that's why I go back to that. All right. So that book review, it's in the place to submit it is in week 3. The other thing that, did you have a question, Charles? Okay, just making sure. The other thing that's in here, and we will not have time to really do this, so I've done it just to make sure that you get the material. There's homework for chapters 7 through 9. So you'll have to go back and look in the book. Our book is really, really good. So I'm going to switch back to the document camera. Our
Do
book.
we need to do the homework on the mind tap?
I didn't do the homework on the mind tap. I did it in Blackboard.
Okay, well, I happened to do last night's, chapter 6's, and it was a lot harder than the one you gave.
Yeah, it was hard.
What, in mind tap?
Yeah, mind tap was very difficult. I think I got a 66 on that. I missed 5 questions.
Yeah, because the homework that I'm typically taking credit for is because I don't remember setting up the homework in mind tap.
It's just confusing me sometimes because you put homework on Blackboard, but then it'll sometimes have homework on the chapters and it'll say count towards grade or something like that.
Oh, well, in mind tap, I haven't been using anything except one time early on in the semester. I haven't set up anything in homework in mind tap. So what that is in mind tap is the packaged course that came with mind tap.
So just don't do it.
You can do it to expand what you're doing, but I'm not counting it towards the grade.
Makes me feel better.
Yeah, I'm not counting it towards the grade. Partially because I just haven't dived into mind tap yet to figure out exactly how it's all working, and I've been juggling actual content of this class. And so what you're seeing in mind tap right now is whatever the authors of the book thought was important for homework, which actually isn't a bad thing to go in and look and see what the authors of the book think for homework is a good idea. But what I'm counting is what I've put in Blackboard.
Yeah, it had us doing homogeneous units, making sure that all the units within that problem were homogeneous.
Well, that's a good practice. I like that problem.
The problem is it just listed variables like what is K for this formula, and it's just like, what is this formula? I've never seen it in my life.
And it wasn't in the book.
Well, like if you're doing K, was it PV equal N? Oh, well, if it's K, it's going to be the Boltzmann one. Probably going to have pressure, volume, and temperature.
It had a I think Q1 and times Q2 over C, I believe.
Okay.
Or it was either C or M, but it was K times that, and it was C equals K Q1 minus Q2 over another variable. I think it was meters squared.
Okay. Was it meters squared or was it kilograms?
I honestly cannot remember.
Because if I have Q is generally heat. The big C is generally heat capacity. So that's going to be, it's going to be joules per unit. So that heat capacity is like joules per unit mass. M in that one is not meters. M in that one would be mass. And then you're looking for whatever the units on the constant would be. So think about it this way, for those of you who have at least had seen it before. So let's take force is equal to mass times acceleration, right? And then if I go in and I use Newton's law of gravitation, which is F is equal to big G, the universal gravitational constant, M for mass 1, M for mass 2 over R squared. The question is, what does G have to have, what units does G have to be in order to have F in newtons? That's what those problems are getting at. And those problems are really going to be helpful in chemistry and in physics.
Yeah, some of them I actually have been doing in chemistry, so it was like a little refresher, like, oh, hey, I've done this, I know this one.
Right. And so that's what that one is. And those types of problems, and I can tell you why the author feels that those are important, because if you do that, if you do those types of problems, you're going to be able to work through lots of your problems in thermodynamics. You're going to be able to work through lots of your problems in physics. You're going to be able to work through lots of your problems in chemistry, a lot of your engineering classes, just by watching unit analysis. just by keeping that unit analysis there. So I'm getting this out so we could look at what chapters 7, 8, and 9 are for. And chapter 7 looks at length and looks at length-related variables in engineering. So what it's doing, what this author's doing is giving you some fundamental tools that you're going to use in a lot of different classes. And it's going at basically like what's length, where's that length coming from, how is that going to go. Then we've got time and time-related variables, and we've got mass and mass-related variables. Remember, my fundamental units are going to be length, because length will be able to make area, and length will be able to make volume. Those are going to be derived units. Time, because I'm going to work with length and time to give me velocity. I'm going to work with length and time squared to give me acceleration. Mass, which is going to be my kilograms or my slugs or whatever, those end up going and coming together to form my other units. Joules are Newton meter, which is a kilogram meter squared second squared. Kilograms, mass, and seconds are all my fundamental units, and I'm going to ultimately end up in dealing with related variables that are going to be associated with that. The other one that we don't talk about as a fundamental one, but it is, and we'll get there in a little bit, is charge. Charge is coulombs, and so if I have coulomb seconds, I get current, which is an ampere. So you start thinking of what are my fundamental units. Charge, coulombs, are my fundamental units, and how those are going to come together. So this is ultimately going to be a good resource for you. But to simplify things, I'm having you do the homework on Blackboard. But I would encourage you to look at what the author is actually having you do, because it's certainly it's certainly a good way to get them build those fundamental skills that you need. Totally a good way to build those fundamental skills that you need. And if you look at the slide deck this author provides for these chapters, you'd have to be meeting 3 times a week in order to get through all the material that this guy wants you to get through. Which is good, but we don't have that kind of time. And this is an introductory survey course. And when I talk to OSU, I'm making sure you guys get everything that OSU wants you to get. And the big thing that OSU wants you to get is a general idea of what the differences are between the different types of engineering and the differences and challenges that we face as engineers. The differences and challenges that we face as engineers and those pieces. So if we think about the discussion board, and I really like the discussion board. I went through it yesterday afternoon. I appreciate those of you who have posted, because you guys found some really cool stuff. Although I do have to laugh about Y2K being an engineering mistake. Because it certainly wasn't. Now, the fiasco that associated with Y2K, that could have been led up to some sorts of engineering mistakes. But the ultimate why we did years in 2 digits versus 4 digits was not an engineering mistake. It was an engineering choice. And when that choice was made in the 1940s, in the 1940s and the 1950s, was very important. And to me, the fact that people point to Y2K being an engineering mistake is a bigger problem today that relates back to what happened last week. So, my first computer I worked with was one we put together in our electronics class. And it was 63K of RAM.
Wow.
Okay, 63K of RAM. And I'm sure most of you have ever heard about the killer app, all right? The killer app is the use of a tool or whatever tool that makes something become ubiquitous. The killer app for computing is the spreadsheet. And the spreadsheet really doesn't show up until the 70s. Okay, spreadsheet really doesn't show up until the 70s. That's the killer app for what made personal computers and everything become, and for business, everything going out there to have that spreadsheet became the killer app. Because up until then, computers were essentially glorified calculators. Okay? We use them for massive calculations, and I've said this many, many times, your cell phone has more power in it than what all the computing power that went into the Apollo space launch. Your cell phone has more computing power than those people who went to the moon had on the rocket. So what happened and why Y2K was, quote, a fiasco, is because if I only have 63K of memory to work with, I've got to do something to shortcut because of all my bytes. And remember, a byte is a 1 or a 0. I actually used to have a jar of hard memory. Hardcore memory, which were little magnetic discs with 2 wires through them. And it's whether or not you had the magnetic field go one way or you had the magnetic field go the other way, which is whether I had a 1 or a 0. So if I'm dealing with magnetic circles being my memory, and I've got to do 1s and 0s to do my 9s, and if anybody's ever counted in binary, the number 9 is lots of 1s and 0s. Okay, the number 9 is lots of 1s and 0s. So if you think about I have to have a magnet for every 1 and 0 that I have, that's a heck of a lot of memory that's chewed up into a 2-digit number. So if memory is expensive, I'm not going to do a 4-digit number for a year. I'm going to do a 2-digit number for a year, and I'm going to save my memory for something else. So one memory, it's novel to me to have a USB drive that has 32 gigs of memory, and that we use it up. Because my first computers, 16K, 63K, a floppy disk. My first floppy disks were foot by foot. Then there were the 3.5 inchers. Then there were the 2.5 incher hard ones. Then we had the big ones that were zip drives. Zip drives only lasted for a little while, by the way. So if you start looking at that, Y2K was not an engineering disaster from the fact that somebody made a mistake. No, they made an engineering choice based on the technology that we had at the time. Totally made an engineering choice based on the technology that we had at the time. What was making everybody freak out was a problem that I actually encountered in the refinery. If you hardwired a chip to do a task, and I had a chip that ran my instrument that was required for the Environmental Protection Agency, that chip ran my instrument 365 days a year, 24 hours a day, 7 days a week. We hit leap day. The engineer who programmed the chip forgot that once every 4 years there was an extra day thrown in. My instrument coughed, sputtered, and died. Because the engineer forgot that once every 4 years you had to make a correction and you had to throw in the day. And because we had so many hardwired chips in all the electronics in the 90s, nobody knew for sure what was going to happen when we tripped over and we had that we went from 1999 to 2000. And we went from 99 to 00, and the calculations, like how old is a person, was all based off of 2-digit numbers. Nobody knew. And that's what the fiasco was, because we didn't know. And most of us who have had instruments that died because of leap day were terrified. That's why we had everybody at the refinery. We actually celebrated New Year's Eve at the refinery because we didn't know if there was a piece of equipment out there that was going to shut the whole thing down. We did not know if there was a remote power supply somewhere that the chip wouldn't hold. We didn't know. And you couldn't be for sure. Now what was good is as it tripped over in Borneo It tripped over in third world countries and their power grids did not come crashing down. We all knew we were going to get to have a party because everything was going to be just fine.
So you were celebrating because nothing broke.
Well, we ended up celebrating, but that was a year that year because we lived in Borger, Texas. The whole, everybody works in Borger, Texas. All works for the refinery, or related to the refinery or some such thing. We actually had a community-wide New Year's Eve party in a big gym, so that everybody was there and nobody had vacation, and we were all there just in case something happened. And so we had a big, huge community party, and it was actually a blast. We actually had a great time. Because everybody knew we weren't going to have to be running out and taking care of something. And if we were, it was just going to be the usual or the usual malfunction that we had to deal with, not something because of Y2K. So Y2K was not an engineering mistake. It did cost us a heck of a lot of money, but it was based off of an engineering choice based on the cost of memory. And that's what's happening right now. Memory is so cheap that people don't program cleanly. Memory is so cheap that I hate apps that eat up my battery because somebody's sloppy programmed. That's why an app will eat up your batteries, because they've sloppily programmed. That's why having a non-compiled language like Python or BASIC or something like that creates other problems, because that's what ends up. So last week, Microsoft Windows came out with an update. I guess it was last week. Sometime within the last 10 days, Microsoft Windows came up with an update. Some sloppy programmer did not take care of the temporary files properly and became a memory hog on people's computers. And it was really interesting is because those temporary files help keep track of where things are. So if you took memory, or if you took a file off of your hard drive and put it onto a storage device, so for every gig of memory you took off, this file generated a gig of information. I took off 27 gigs of memory off of my computer, 27 gigs of files off of my computer. My computer still said I only had 1 gig of memory available to work with. I took off 27 gigs, and I was about to shut down, to the point that my computer was about to shut down because it wouldn't be able to turn off and on because of somebody's sloppy programming. And apps are notorious because people say, well, I'm going to take this bit of code here and this bit of code there, and because memory's cheap, I don't have to streamline my programming. And because I don't have to streamline my programming, it's going to eat. That's why as each iteration of our operating systems come up, it takes more and more RAM to do what they're doing because they're not cleaning it up. And the legacy of Y2K the legacy of the fact that memory was expensive, was we did really cool, clean, efficient programming. Because we only had so much memory to work with before we shut things down. So to me, Y2K was not a problem. Well, it was a problem, but it was not an engineering mistake. And the bad part is we're pointing to it as an engineering mistake, and we shouldn't be learning for why the thing was in there in the first place, because right now I can put an app on my phone and it'll eat up the memory on my phone, and it becomes a pain in the tush, and my phone no longer becomes the tool that I want it to be. And that's really, really frustrating for those of us who lived through all of those lovely programmings and lived through Fortran. I love Fortran. Fortran is a very nice, clean language to program in, and physicists still use it because it's a nice, clean language to program in, and it's efficient. But now we have all this other lovely stuff that just, Now, my first computers were 63K. I actually worked with a paper tape computer. That actually, how you stored your memory and stuff was paper tape. I used a PDP-8, PDP-11. I have examples of floppy disks from all the various things. It's pretty cool stuff. So you got your homework for those chapters. Book reviews are due next week. I need the sign-up sheet for wherever it's worked out. I will tell you guys over in Enid, I will not be over on November the 15th. So for your Panda planner, I did post that on, I'm going to switch it over so you've got that. That your Panda planner, make sure remind you that it's due. I have it due that you have to come talk to me by November the 22nd, but that's why I'm telling you guys over in Enid that I won't be over on the 15th, which really only gives you this Friday and the 22nd to come meet with me in person. We can set up a Zoom if we need to, if that's helpful for you, but I will not be over on the 14th. But you got to come by my office, get in there. You get base 65 points for coming in and meeting with me. There's articulating how you use it's up to another 20 points. They get you 85 points. Demonstration of the utility and all of that's another 15 points. So the big part is come in and see me and talk about your planner. If the 22nd is the Friday before Thanksgiving week, and if you don't come and see me, before the 22nd, you will still get credit for your planner, but it drops by 10 points every day after the week of Thanksgiving. So that week of Thanksgiving is a freebie, but starting that Monday, that week of December 2nd, it drops by 10 points, and no points will be available after December 6th. Our final in here is that Tuesday of finals week, and it will be very, very much like the midterm, and you would expect to see some of the same types of questions that were on the midterm on the final. But the big point things that are coming up are the Panda Planner, the book review, and the TED Talks discussion boards, and then we've just got a few more homework pieces that are in there. And lucky for you guys, that means no more memos. We're done with memos. After the book review, we're done with memos.
I was just getting proficient at them.
That's the point! Yes! Yes. What?
So you'll do a ton of them.
You're going to do a ton of them.
Do we have a discussion board post this week?
I have not posted one for this week. There won't be one for this week because I'm giving you time to do the book review. Now, that doesn't mean that you can't go in and post more stuff on the TED Talk ones, because there's been a lot of stuff that's come out in this last week. I've seen more stuff in the last 2 days that have been, there's an interesting study for those of you who might get seasonal depression, that the people in northern Norway that are in 4 months out of the year that they don't have seasonal depression. It's really there are a couple of really interesting things of what they're doing that stays off seasonal depression. It's kind of an interesting situation. It's a lot of it's cultural, but there's some really cool stuff that's come out in the last week or so about some different types of different types of science, different types of things that are going on, and it's gonna be really interesting to see what happens. But yeah, so that leaves it for you guys. So for you guys over in Enid.